Hello everyone, welcome back to another video. In today's video, we will see our final operator, that is shift operator. What a shift operator? It is used to shift bits of non-decimal number data type, that is byte, short, int, long, to left or right side. What it means to shift the bits to left or right, we will see in IntelliJ IDEA. So there are three types of shift operator: left shift, right shift, and unsigned right shift. So let's open our IntelliJ IDEA, and there only we will directly see how it works. I have opened my IntelliJ IDEA. I will close this tab. I will go ahead and create a new class, shift operator. So my class is ready. I will create main method inside this class. Now, first we will see what are left shift operator. Suppose we have a number of integer type, variable name is num, value is 20. So the binary representation of this decimal number will be 10100. We know how to convert decimal to binary, we have seen in a previous video. Now we will see how left shift operator works. So suppose if I do num left shift by 1. So what it means? The symbol for left shift operator is two opening angle brackets. So what I am doing here, I am telling to shift this entire bit to left side by one position. If I take this number, so I have taken this number, shift this number to left side by one position and add 0 in the remaining position. So this is how left shift operator works. It will take the entire bit, it will shift the bit to left side, and it will add 1 0 in the vacant position which is created. Suppose if I write 2 here, what it means, it will take this number, it will shift the entire bit by two position to the left side, 1 2. So the bit is shifted to two position and 0 will be added to the vacant position. So this is how left shift operator works. Now if we convert this binary to decimal, we know how to convert this binary to decimal. We have seen in a previous video. So how it will happen? We have to start from the least significant bit, that is this bit. We have to take this bit 0 multiplied by 2 raised to 0. Then we have to add this number with 0 multiplied by 2 raised to 1. Now plus 0 multiplied by 2 raised to 2. Again plus 0 multiplied by 2 raised to 3. Now again plus, now 1 multiplied by 2 raised to 4. Again plus 0 multiplied by 2 raised to 5. Again plus 1 multiplied by 2 raised to 6. Now if we do addition of these numbers, we will get 64 plus this will be 0 plus this will be 16 plus this will be 0 plus 0 plus 0 and plus 0. So we should get output as 80. We have seen this is happening in our last video as well. Now if I run this code, I should get output as 80. Yeah. So this is how left shift operator works. Now similarly, what will happen with right shift operator? Instead of shifting to left side, it will shift the bits to right side. So we will take the same number. I will comment this piece of code. We'll write num right shift by 2. So how it will happen? We will take this number. We are telling take this number, shift this number to right side, means this side, 1 2 by 2 position. So we will get 0 in the remaining position. Shift and replace it by 0. So we will get 0 in the new vacant position, and this bit will be discarded. The shifted bits will be discarded. So I will show you again what I did here. I took the entire bit, I copied the entire bit, shift the bits to right side, 1 2 by 2 position, replace this 2 position by 0, replace 2 vacant position by 0, and discard the rightmost 2 extra bits. I hope it is clear how this is working. So if you convert this binary to decimal, we will get output as 5. So if I run this code, I should get output as 5. Yeah. So this is how right shift operator works. In left shift, we are shifting the entire bits to left side and adding 0 in the remaining vacant position. In right shift, we are shifting the entire bit to right side. We are adding the zeros to the vacant position and removing the extra bits. Now we will see what is unsigned right shift operator. Let's comment unsigned right shift operator. Now, what is the meaning of signed and unsigned? So, signed means the number can be positive or negative, whereas unsigned means the number will always be positive. So, if we look at a right shift operator, we have passed it a positive input, and after right shift operation, we got a positive output. But if we are passing it a negative number, after the right shift operation, we will be getting a negative number. So this right shift operator is signed right shift operator. Whereas in unsigned right shift operator, what will happen? No matter if we are passing it a positive number or negative number, after this unsigned right shift operation, the output we will get will be positive. That's why it is called unsigned right shift operator. So we have seen a positive scenario for right shift operator. What will happen if we take this number as negative? So let's see what will happen if we make this int num as -20. So I will first comment this code and let's take an example for right shift operator for negative number. I will take the same number int num equal to, but this time it will be negative, so -20. Now we will see how right shift operator works in case of negative number. So before going ahead with the operation, first we have to see how this -20 is represented in binary. So what is the binary representation for -20? To get the binary representation of -20, we have to follow certain steps. So the first step is we have to invert all the bits of positive number. What it means? Positive number. What it means? Take the bits of the positive number, that is binary representation of positive number. So this is the binary representation of positive 20. So we have to take this positive representation and we have to invert all the bits. Invert means if the bit is 0, make it 1 and vice versa. So if the bit is 0, make it 1. If the bit is 1, make it 0. So in this case, we know that 32-bit representation of this number will be, we have to write it like this. We were ignoring these zeros previously, but this time we have to consider because we have to invert the bits. So this 0 will be converted to 1. So we have to take this zeros into consideration. So now this is the 32-bit representation of this positive 20. So first step is to invert this bit. So what will be the output after inverting? 0 will be converted to 1. So we will get 4, 5, 6, 7, 8. 8 ones. Then again 8 1, again 8 1, 1 1 1. 1 will be converted to 0, 1, 0, 1 1. So these zeros are converted to 1. 1 is converted to 0. Again 0 is converted to 1. And triple zeros are converted to triple 1. And all this remaining 0 is converted to 1. First step is done. Now the second step is add 1 to inverted bits. So we have to add 1, take this bit, and we have to add 1 to this bit. So after adding, after adding, we will get the binary representation for this number -20. So let's add, we have to add it from the least significant bit from the end. So 1 plus 1 will become 10. As we know in binary, 1 plus 1 is 10. So 1 will be carried over and we will get 0. Now again 1 plus 1, it will be 10. So 1 will be carried and again we will get 0 below. So we will get 0. Now again 1 plus 0 will be 1. So there will be no carry this time, and remaining bits we have to copy as it is because we have nothing to add. So this bit will be copied as it is. So this is the binary representation for negative 20. Now you must have question like how 1 plus 1 is 10 in binary. So similar to decimal number system, if we consider decimal number system, let's consider decimal number system. In decimal number system, we have numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So these 10 numbers are present in decimal number system. So if I want to add 9 plus 1 in decimal number system, how I will do? 9 plus 1. If you want to add 9 plus 1, obviously there is no digit like 10. Because we only have these 10 digit and we want to represent 9 plus 1. So how we do? 1 will be carried over. 1 is carried over. 9 plus 1 we take 0 here and this carry will be taken as it is. So we get 10. Now similarly, if we consider ternary number system. So ternary number system. Ternary number system means it has only three numbers 0, 1, 2. If I want to add 2 plus 1, I will remove this. So now 2, if I want to add 2 plus 1, there is no number to represent 3. Here we only have these 3 digits, but there is 2 plus 1 will be 3. There is no 3 in this number system. So obviously 1 will be carried over and we will get 0 here and 1 as it is. So in ternary number system 2 plus 1 is 10. Similarly, if we consider quaternary number system, it will have four numbers 0, 1, 2, 3. Now, if in this number system I want to do 3 plus 1, there is no digit like 4 to represent 4. It has only 0, 1, 2, 3. So 3 plus 1, 1 will be carried over. We will get 0 here and we will take 1 as it is. So in quaternary number system, 3 plus 1 is 10. Similar to these number system, in binary number system, we only have two numbers 0 and 1. So if we are doing 1 plus 1, there is nothing to represent 2. So in this case 1 plus 1, 1 will be carried over. We will get 0 here, 1 as it is. So that's why 1 plus 1 is 10 in binary number system. I hope it is clear. So I have just explained you why 1 plus 1 is 10 in binary number system. So we will get back to our right shift operator. So here we got binary representation for minus 20. So this is the binary representation for minus 20. Now I will just copy this code down and I will copy its binary representation. So this is the binary representation for minus 20. Now I will apply right shift operator on this number num right shift by 2. In case of signed, this is a signed number. Signed means this is a negative number. So in case of negative number, if we are doing a right shift operator, so obviously we will take this binary representation and we will shift this binary represent to right side. But instead of adding 0 here, which we were adding 0 in case of positive number, but in case of negative number, we have to add 1. After shifting the binary bits, we have to add 1 in case of negative number instead of 0 in case, which we were doing in case of positive number. Here, in case of positive number, we added 0 because 0 represents positive number. But in case of negative number, we have to add 1 because 1 denotes negative number. Since our input is negative, obviously output should be negative. So that's why we are adding 1 in case of negative numbers, and we have to discard these extra bits. So the process is same. We have to shift the bits to right side. We have to add 1 in the empty bits and we have to discard the extra bits. So this is the final output which we got. Now we have to convert this bit. This is a binary representation of our answer, but again we have to convert this binary representation to decimal representation. So how we will do? Again we have to follow the same steps. This step again we have to follow. So I will just copy. First step, invert all the bits of negative binary. So this is the negative binary, this is the output which we got. So first step is to invert all the bits. So we will invert these bits. So after inverting, this will become 0. So this will also become 0. This will also become 0. Triple one. So triple one, triple zero, we will get 1, 0, 0. I will just align these numbers. So now this is the output. Again, we have to follow the second step. Second step is invert all the bits, add 1 to inverted bits. So this is the second step. Now we have to take this inverted bit and add 1 to this bit. So we will get output as 0 plus 1 will be 1 and remaining all the numbers will be same since we don't have anything to add. So this will be same. Now this is the final output. If we convert this binary representation to decimal, we will get output as 5. But we know that since this is a signed operation, we have negative input and output was negative. This is the final output. So its most significant bit is 1. 1 means it's a negative number. So this should be negative. So this will be a negative number. So we should get output as -5. Now let's see if we are getting, this is our code and I have explained you how right shift operator works for negative numbers. So if I run this code, I should get output as -5. Yeah, so I'm getting output as -5. Now we have finally seen both the scenarios. We have taken a positive number, right shift operator with positive number and right shift operator with a negative number. We will see the last operator, that is unsigned right shift operator. So in case of unsigned right shift operator, if we pass it a positive number, suppose if I am passing it number 5, I will comment, first I will comment this code. Now suppose I am passing it a positive 5 and I am doing num. So the symbol for unsigned right shift operator is triple angle brackets. So unsigned right shift operation and by 2. So if I run this, I should get output, positive output. Yeah, I'm getting positive output. Let's take 10. Yeah, I'm getting a positive output in case of a positive number. Now let's see, since this is an unsigned right shift operator, means unsigned means sign is not maintained. Even if I'm passing a negative number, this negative symbol will not be maintained. It will be removed. Okay. So let's see if I run this. Okay. So obviously I have passed a negative number, but I'm getting a positive output. That is for sure because it is an unsigned right shift operator. But I'm getting very huge value. Why I'm getting this huge value? In case of right shift operator, I would have got 2. -2, but in case of unsigned right shift operator, I'm getting this huge value. So let's see why I'm getting this huge value. So if to check that, we will have to first get the binary representation for -10. So let's see what is the binary representation for -10. Now we know how to get the binary representation for numbers. So first step will be get the first step will be invert the bits of positive number. So I will take the binary representation of +10 and I will invert all the bits. So +10 will be represented by 1010. This is the binary representation for number 10. Now I will invert all the bits. So we will take 32-bit representation. So 1, 2, 3, 4, 5, 6, 7, 8. So 8-bit, 16-bit, 24-bit, and 1 2 3 4 1 0 1 0. This is the 32-bit representation for number 10. Now invert all the bits. So I will invert, means 0 will become 1, 0 1 0 1. So bits are inverted. Now second step will be add 1 to inverted bits. So let's take this and add 1 to this. So what will be the output? Output will be 1 plus 1 is 10. We have seen how it comes 10. 1 will be carried over. 1 plus 0 will be 1. And again, we will copy everything as it is. So this is the final binary representation for -10. Now we have to perform this unsigned right shift operator. So how this unsigned right shift operation is done? So I will just copy this piece of code and below here. And now we have this representation for -10. So it will be same, the procedure will be same. Take this number, move it to right side. So shift it to right side by 2. So I will shift this binary representation to right side by 2 bits, 1, 2. I will remove the extra bits from the right side, and in the vacant spaces I have to add 0 instead of 1. Why I am adding 0 here? Because we know this is an unsigned right shift operator. Unsigned right shift operator. So we know that if there is a negative number, it will be converted to positive. So for positive number, we have to add 0. For negative number, we have to add 1. So since this is an unsigned right shift operator, we have to add a positive value. So we will be adding 0. I hope it is clear. Now we got the final output for this unsigned right shift operation. Now if you will convert this number to decimal representation, what will be the output? Let's see. So I will open Google and I will directly search what is the decimal representation of this number. I have shown you how to convert binary to decimal. You can, if you want, you can calculate like that as well. But as of now, I will check on Google what is the decimal value for this binary number. So I will open Google binary to decimal. So I will just enter my binary number, convert. So this is the value which we are seeing here as well. I will copy here and I will copy here. If you see, both the values are same. That means our code is working properly. And I have shown you internally what is happening at the bit level. Now we will see some practical use case where you can actually use this right shift and left shift operator. So I will go ahead and create another variable num. First I will comment this piece of code. Suppose inside this variable I will allocate number 5 and binary representation for 5 is 101. Now suppose I want to multiply this number by 2. So what I can do, I can simply write num equal to num left shift by 1. So here what I am doing, I am just taking this binary representation and I am shifting the representation to left side. So this is the binary representation for 5. I'm telling shift this binary representation to left side and replace the vacant position by 0. So this will be the output for this operation. And if you convert this output to decimal, you will get 10. So I have multiplied this number by 2. So if I print the value of num, I should get output as 10. Yeah, I'm getting output as 10. Now, if you want to multiply this number again by 2, you can simply write 2. So, what will happen here? Now, this representation will be shifted to 2 position on the left side. So, 1, 2, and the remaining vacant position will be replaced by 0. So, 0, 0. Now, this is the binary representation for 20. So, you have multiplied 5 2 times. So, this means 5 multiplied by 2 multiplied by 2. So you should get output as 5 2s are 10 2s are 20. So if I run this, I will get output as 20. Now if you multiply this number one more time by 2, you can replace this 2 by 3. So you will get output as 5 into 2 into 2 into 2. That should be 40. So I hope it is clear. If you want to multiply a number by 2, you can go for left shift operator. So this is one of the use case for left shift operator. Similarly, for right shift operator, I will write example 1 multiply by 2 using left shift operator. Now similarly, if you want to divide a number by 2, example 2, if you want to divide any number by 2, you can go for right shift operator. Let's see an example for it. First, I will comment this piece of code. Int num equal to 40. And the binary representation for 40 is 101000. So this is the binary representation for 40. I want to divide this number by 2. So num equal to num right shift by 1. So here I am telling take this binary representation and shift it to right side by 1 position, discard the extra bit and replace the new position or vacant position by 0. So if you see, this is the binary representation for 20. So what has happened here? 40 divided by 20. Sorry, 40 divided by 2. So we will get output as 20. If I print this, I should get output as 20. Yeah, so by using right shift operator, you can divide the number by 2. Now, if you make this 2, this number will be divided 2 times. So basically, this will happen 2 multiplied by 2, 40 divided by 4. So in terms of bit, this bit will be copied. It will be shifted to right side by 2 position 1, 2. Extra bits will be discarded. New vacant position will be replaced by 0. So this is the binary representation for 10. So if I print it, I will get 10. If you do 3, this will be divided by 2 multiplied by 2 multiplied by 2. And again, this will be shifted again to right side. Extra bit will be discarded. Empty position or vacant position will be filled with 0. And this is the binary representation for 5. So we will get output as 5. So this is how it works. So this is how you can use left shift operator or right shift operator for doing multiplication or division. So that was all for this video. We have seen left shift operator, right shift operator, and right shift operator for positive number, negative number, and unsigned right shift operator. I hope it was clear, and if you have any doubts, you can mention it in the comment section. Thank you for watching. See you in the next video.